Here is procedure DFS01, a recursive version of depth-first search with no precondition. When procedure DFS1 is called, U may or may not have already been visited. If U is already visited, no nodes are to be visited, so the method returns immediately. On the other hand, if U is not yet visited, we visit it, and then a call to dfs1w is executed for each neighbor w of U. Assume we are working with a directed graph with m nodes. Suppose that the initial call dfs1u requires n nodes to be visited and that, in total, these n nodes have e edges leaving them. As an aside, if u is already visited, n and e are both 0. We determine the number of times each statement in dfs1 is executed. First, the if statement is executed at the beginning of the first call dfs1u. Second, the if condition should be false exactly n times, because n unvisited nodes are to be visited, and if it is false, node u is immediately visited. This means that visit u is executed n times. Therefore, the for each loop is executed n times, once for each node that is visited. That means that a recursive call dfs1w is made for every neighbor of every one of the n nodes, which means a total of e times. But then the if statement is executed another e times, once for each recursive call. Since the if condition is false n times, it is true 1 plus e minus n times, so that the return statement is executed 1 plus e minus n times. Note that we are not describing the complexity of executing the for each loop. We cannot do that unless we know how the graph is implemented. If the graph is implemented using an adjacency list, so that each list of outgoing edges is in an array or linked list, the time is proportional to the out degree of the node. It could be the number of nodes in the graph. This method makes e recursive calls, one for each edge, leaving one of the nodes to be visited. If the graph is dense, this is very expensive. It could be quadratic in the number of nodes in the graph. That could be a lot bigger than n, the number of nodes to be visited. To reduce the number of calls, call dfs1w only if w is not yet visited. The if statement is then executed e times, but the recursive call is executed only n-1 times in total. This means that the first if statement is executed n times. It is false at most once, only if the first node is already visited. The if statement in the loop body is not needed for correctness, but is essential for execution speed if DFS1 is going to be used on large graphs.